So, we're at an HTML5 Developers Conference. HTML5 is awesome. It's given us a lot of tools and new toys to play with, and we have some really awesome browsers compared to what we had a few years ago. We have vector graphics, real-time web communications with WebSockets, WebRTC, fast graphics performance, hardware acceleration, all kinds of fun stuff that lets us build amazing applications. But HTML5 is an incomplete story. And for us at Sencha, we build a lot of HTML5 applications with our frameworks. Most of our customers are large corporations building business-critical applications. And there's some features that are missing. So for us, we asked, what do we want to do about the enterprise? And we came to this conclusion after hearing many, many stories from a lot of our customers that the current crop of browsers, while as technologically advanced as they are a very poor deployment choice inside of the enterprise. And what it turns out is that all of these browsers, every single one from the ones on your phone to your desktop, are generally optimized for consumers. And so we have one deployment platform for everybody. Whether you're surfing Facebook or whether you're surfing your ERP system, your CRM system, they're more concerned about protecting you from the sites you visit than the other way around. And enterprises generally know who their users are. They generally can keep the users out that they don't want in, and they want to know who a user is before they access a site. And so there are some missing features from today's crop of consumer browsers. And so on native, on the mobile platform, we said, OK, well, let's do packaging. And packaging has kind of been our solution for deploying on mobile for the last couple of years. Cordova, in particular, has done a great job of creating a really rich HTML5 experience inside of a native package. And our tools fully, as of the most recent release of Sencha Touch, fully support Cordova. But we found that packaging introduces some compromises, some burdens that we, as web developers, generally don't want to have to deal with. So when you package an app, you're beholden to the App Store with which you publish it into. If you look at Apple, it takes several days to a week, maybe more, to get your app, even minor updates, approved. And then for every platform that you support, you have to package it separately, deploy it separately, and figure out exactly what the rules are for each app store. And now there's some tools that have been built to make this as easy as possible. But when you try to scale this at the enterprise, where you're building dozens, if not hundreds, of applications across a large company, it starts to break down at scale. And really, we think there's something missing here. But it's really all we have today. The other thing that's been happening in the last couple of years is bring your own device. And users are no longer happy with the company-provided BlackBerry, and they want to use their iPhone or their brand new Android device. They don't want to wait for some IT person to decide to send them a new one. They don't want to carry around multiple devices, one for work and one for business, and one for their personal stuff. And so corporations en masse are trying to adopt this bring your own device type environment where users can bring their devices and then they put their corporate data on it. But there's a lot of compromises with those current solutions as well, because basically, if you are working at a company that uses one of the mobile management platforms out there, you're basically handing them your device, and then they get to decide what goes on your device. They get to decide which networks you can connect to. They basically install a rootkit on your phone and install some proprietary software. They then have access to all the apps that are on your phone. They know exactly what you're doing, when you're doing, and where you're doing it. And that we don't think is a great solution either. It's a big burden for the IT department because now they have all these hundreds, or not, if not thousands, or tens of thousands of devices to manage. But it's also burdensome for the user because you've now compromised your device. So that is what we think the problems are with the current bring your own device environment, with the tools out there that are available to you as an enterprise. So what can we do as an HTML5 company to bring together the world of the web and at the same time having an environment that is optimized for business? And back in July, we introduced our latest product called Sencha Space. And this is our product, this is our solution that we think brings together the web and the enterprise in an environment that works for both. So what is it? So it's two things. The first one is an app that lives on your phone, and it comes in, on Android and Apple and BlackBerry and whatever platform you happen to bring that you happen to bring into the office. And that's the environment. That's what you use to access your corporate data. One app and nothing else. And on the IT side, you get a nice dashboard where you can control who has access to that app, and then what do they see once they get in there. You can see who's using the app, where they're using it from. You can get good metrics, but really all you have access to on the user's phone is your corporate data and nothing else. Oops. So, and on top of that, what we want to add is a significant layer of encryption and give you a secure browsing environment that when your data leaves your corporate firewalls, you can be assured that it's going to be protected. We want to keep your work apps separate from your personal apps. And we want to be able to allow your IT department to manage access to those apps. And most importantly, your existing HTML5 assets and apps need to just work. So I want to give it, show you exactly what this is. I've got a little demo set up, so hopefully if I can make the transition to wake up my phone. So there we go. So this is my phone. This is my personal phone. It's got all my junk on it, all the apps that I use. And then down here in the corner, I've got this the Sencha Space app. And so when I open that up, I get a list of all the organizations that I belong to. And this is another important feature of Sencha Space is, unlike a regular browser, you have a isolated browsing environment for each one of the organizations you belong to. And this will become, and I'll show you the details of how this works. So I can go into the demo environment. And what we're doing here is we're actually, if I hit the right button, let me go back here. When you try to access your organization, you're presented with a pen screen. And this is what we use to encrypt the data on a per organization basis. So you don't have to, that's the wrong pen. This is how we keep your encryption keys safe. And this is the thing that we use to secure your environment. So when you first log in, I thought I had a, oh, that's not apparently working. Sorry. So when you first log in, you get access to your corporate homepage. This can be any web page that your corporation might have. And once you tap on the menu here, you get a list of all of your applications. And here we have a few demo applications that we put in just to demonstrate how this works. So we have an emergency contacts app. This happens to be written in Sencha Touch. You can scroll through and see all the different emergency contacts that you might need. HR, IT, facilities, whatnot. Because this is a browser, we give you forward and back buttons, so you can go from one screen and then back to the next and navigate just like you would with a web browser. You can favorite links or subpages underneath the application. So if I expose this here, you can see the different things that I bookmark, the things that I use most frequently. And in the event of a zombie attack, for example, I can quickly get access to the zombie contact information page. So that is kind of how Sencha Space works. we have a bunch of different applications in here. We have a chat application. And these are just whatever applications your corporation has, or whatever your enterprise environment has. And one of the other features we have in Sencha Space that we think is important for a business environment is these apps need to be able to talk to each other. With the web, you can't really link deeply between applications in a really meaningful way. You can't, inside of the container, have applications communicate with each other. And so we've developed this new API that allows applications to do just that. And so if I go back here to the IT contact page, and right here there's a chat link. So what I can do is I can tap on the chat link, and now I've been taken to the chat application. You can see if I go back to the menu, I'm now in the chat application. So this is one of the cool things we can now do with Space, is I can link applications together. And it goes beyond just linking. I can, inside of the chat application, we've hooked it up. I'll just type in some garbage here. But we also have a to-do application. So any line item you have in your chat, you can now create a to-do list. So if this is a bit of a wired demo, but basically I can say, oh, okay, well, I've got this meeting, and I need to do some, I need to create a to-do for this list of stuff for the product. So I say yes, and now I'm switched over to, after it loads, I'm on an LTE connection, so this might be a little slow. I'm switched over to our to-do application, where I now have a dialogue pre-populated with the text from the chat application. So now I have one application talking to another application and sending it data. And then when I'm done, I can say add, and it takes me right back to where I started. So we've created a new way of doing interactions between web applications inside of a container. There's no server involved. I can turn off my LTE connection, and I can do this completely while I'm offline. And we think that's actually a pretty powerful way to build applications. And I'll go into more detail on that, on how you actually do that in a minute. But let me go ahead and switch back to the slides. Come back. Yes. All right. So let's take a look at how is this different than native packagers are today. So with native packagers, we all start with a web view. Everybody just starts with a web view. And whether you're using Cordova or rolling your own, you start with a web view. And then in the case of Cordova, they've got a rich environment full of awesome plugins that you can then connect into this web view. And that's a pretty good way of building pluggable functionality. So you can add barcode scanners and any kind of proprietary plugins you might need, security, cryptography, all that stuff. But that's what you can do with Cordova. This is what you can do. This is how Sencha Space works. So inside of the Space client, again, we start with the web view. And each application, in our case, gets its own web view. So as you saw when I was switching back and forth between applications, I could do that without reloading, because we're maintaining multiple web views inside of the same container, and we're just swapping out which one is visible. It's also the same way our Invoke capability works, where we can actually communicate between web apps. And on top of that, or below that really, we've added an encrypted file system, an encrypted database, and a set of isolated native APIs. And to make all that work, we created using industry standard technology, an encrypted backplane. And all of the encryption that we do is run through this library. And then in the space between the encryption library and the web views, we create a policy engine that basically grants web views access to the specific functionality, and more importantly, the access to the native APIs. So you can build applications, and then your administrator can say, this application should have access to the encrypted database, this application should have access to photos, contacts or whatever native APIs are available. And it can be controlled on a per application basis. And on top of all of this, we have our Invoke API, which allows the web views to talk to one another. So as I mentioned before, encryption isn't something you want to invent. Yeah, there's lots and lots of standards and open source libraries and so forth that give you a set of best practices. They're not exactly the easiest thing to cobble together, but if you know what you're doing, you can put them together to make a really secure environment. And so we use things like AES 256-bit encryption, SHA-256, and PBKBF2, which is used for derivation functions, scrypt, which is used for arbitrarily complex salting and hashing for passwords. We use OpenSSL, and for the database, we use SQL Cipher. SQL Cipher is really cool because you can actually do page-level decryption of your database, so you don't have to decrypt the entire database to get access to data. You just have to decrypt the pages of data that have the bits that you need. And so you get really fast decryption with something like SQL Cipher. SQL Cipher is open source. There's a PhoneGap plugin for it as well. But basically, we wrap this stuff all together to create a fairly good and robust environment. So how does that compare to HTML5, and what does that give you out of the box? Why did we go to all this trouble to put all of this encryption into our product? Well, it turns out that the web view, whether you're on Android or iOS, leaves all of the stuff that you do when you're browsing in the clear in text files. Cookies, SQLite databases, local storage, caches, everything is just left laying on the file system. And the applications, the browsers, and let me be specific. This applies whether you're using Safari on your iPhone or whether you're using a native wrapped app that uses a web view. Even if you've got a banking app or any other kind of application that might look like a native app but uses a web view, which is a large percentage of most native applications, this is what happens when you browse. Any file that's loaded in that web view, the data can leak out of it and is left on the file system. And they do that because they can rely on, they rely on the operating system to provide security. And the story on that is a little mixed. So iOS offers full disk encryption if you turn on the pen screen lock. So if you have an iOS device and don't have pen lock on, turn it on now. Because you don't have a whole lot of, you don't get a whole lot of security if you don't have it turned on. That's why I think on iOS 7 they default it to on now instead of defaulted off. So you have to elect to not turn it on. And Android really doesn't have a whole lot of security when it comes to encryption at all. They don't have, there's a very limited set of options for full disk encryption. And so your applications, particularly on Android, are just left in the clear. And there have been numerous reports of, if you look at Android and where they keep all the passwords that you pre-fill on your web forms in the clear. The file system has a permissions-based security system where they just do access controls, but if you root your phone, basically the list goes on. So if you were to hire a security firm, which we did, they'll scare you pretty bad about how and why you will be attacked and how you will lose all of your data. And enterprises already know this, and this is why they're behaving the way, why they're asking for these kind of products. They've been trying to build them on their own for a long time now and have had limited success. So what do we do? What does Space do? So we take all of those files, your caches, your local storage, cookies, everything, and we put it inside of a box, or really a folder, right? We move it out of the location where it normally goes. And we then encrypt the box whenever the application is in the background. And then we do the reverse. When we bring the application to the foreground, we decrypt all the assets, and then your web view can go on its merry way. And the reason why we have to do this is because both Android and iOS don't give you the ability to intercept file system access inside of your browser. So we have to go to these extreme measures, and I'll show you this in just a second. And because we allow you to have access to multiple organizations, we have multiple boxes on which to put your stuff. So as you switch between one organization to the next, you don't end up sharing cookies between the two. So if you're a salesperson and you work for multiple companies and you have multiple Salesforce logins, you can keep the cookies from each one in an isolated location. And we give you a good user experience on how to do that. So let me switch over to let's show you how this actually looks. If you haven't torn apart I'll do a little fake hacking here. So I have two applications, or actually I have the Space application that I've actually downloaded from my phone a couple days ago, and just to show you what's some of the stuff that just gets left laying around. So first I'll show you the unencrypted version. And so this is the app data folder. Inside of the library, there's a caches folder. And this is where WebKit leaves all of its bits. So you have all of your local storage databases on a per domain basis, which, if you're familiar with the domain-based model for local storage and cookies, they all get their own set of files. And I happen to have Google or Gmail. I'm logged into Gmail on this guy here in this particular organization. So if I pull this up, I've got a SQLite browser. And let's see, what do we have in here? Oh, cached messages. That looks interesting. So I go in here, like, oh, let's scroll over here. Oh, look, I've got all of my email and the preview message and who I sent it to. And I've got cached conversations. I've got where I get email transactions. So there could be passwords in here. There could be all kinds of goodies that get sent around. You know what you send around in email. Yeah, I've got all kinds of good stuff in here. And I didn't scrub this list, so there's lots of bugs and security reports and all kinds of interesting stuff in here. So this is what you get when you use a web view by default. It's unsafe by default, and Gmail is great because it actually uses SQL, a web SQL database to cache its data, so you don't have to download it every single time. That's great. However, this is what you get. So if someone were to, if you don't put a pin lock on your screen on your iPhone, and you happen to leave it laying around at a bar or at a conference, and somebody picks it up and might decide to do some malicious stuff with your data. But in contrast, what we do in Space, like I said, we take each, so this is the running version. This is what the web view is doing. And so then I put the app into the background and then took another snapshot of the app, what you'd normally find if the app was off. And so this is what's, everything disappears from the caches folder, except for some stuff that we don't really care about. And over here in the application support directory, we have the place where we put all of our stuff. And so now I've got the JSON Corp organization that I was in, the email address that or the account that I logged into, and then now I've got the Gmail database URL. But if I try to double click on this thing, it actually crashes the app because it is an encrypted file. It doesn't even know what it is. It can't read it. And this particular SQLite database viewer actually crashes when it finds something that it doesn't know what to do with. If I pull it open in something like simple text, it's completely unreadable. It's just random bits. So that's the difference between, and this is why we actually spent a great deal of time trying to get this to work. And it's actually pretty cool if you care about security. So let me get back into the presentation. So that takes care of your out-of-the-box HTML5 assets, all your cookies. But where else you can store your data? HTML, if you're familiar with the Web SQL standard, which is or the local storage standard, you have limited storage options. You can only store 5 or 6 megabytes of 10 megabytes maybe of data locally. And so what we wanted to do is beyond just giving you security, we wanted to give you a new API and maybe push the boundaries of what you can store in a browser realistically. So cookies, they're way too small. Local storage, also too small, but slightly bigger, and it's also a synchronous API. WebSQL was cool because you could do queries, but they deprecated it. And IndexedDB is the new standard, but not very many browsers support it. So if you're trying to do cross-platform packaged apps, it'll work. It won't really, IndexedDB is not available to you right now. So what do we do inside of Sencha Space? We give you an API where every application inside of an organization has its own encrypted database. And we call this secure local storage. So we wanted to basically recreate local storage in a secure way. So when you write data into with our API, it is immediately encrypted using the encryption algorithms that I had a few slides back. We basically take the limits off your storage. So you can fill up your entire application if you want to with lots of data. We give you some convenience methods to create multiple collections per application. So that way, if you're familiar with local storage, you have to do namespacing on your own. We give you namespaces inside of your collections, inside of local storage, so you don't have to do it manually. And we do everything asynchronously, unlike local storage, using the Promises API. Wait, what's the Promises API? So has anybody played with the Promises spec and standard and a few of the implementations out there? All right. So Promises is a standard. It's going through the standardization process right now. It'll probably be part of the next version of JavaScript or the DOM standard. It hasn't quite been finalized yet, but you can keep track of the progress at promisesaplus.com. It's something a lot of people have been working on. There's already a lot of existing implementations, and it's actually some pretty cool stuff. But basically, a promise is a new way of doing asynchronous programming where you get a reference to an object that eventually will have the data that you want. So what does that look like? EXT, in our case, we have an EXT promise. You create one, and at some point later, maybe you've fetched some data from an AJAX request on a database query, who knows what, it doesn't really matter. You fulfill that request with the data that you want, that was for the operation. Or if you have a problem, you can reject the promise. What does that look like if you actually build one? So just a simple example of a wait timer built with promises. Define a function called wait. You give it a time in milliseconds. You create your promise. You call set timeout just to do the actual waiting. And then after the timeout fires, you fulfill the promise. And most importantly, you have to return the promise to whoever called you so that they can actually act on it when it's done. So what does it look like to consume a promise? You call wait with some amount of time, and then you say then, and you give it two callback functions, success or failure. So failure, something went wrong. Success, awesome, my time elapsed. I think that's all I have about promises. Promises are really cool in their simple form. They're not much more interesting than a callback structure, but you can actually do really interesting things with the promises. You can chain them, you can collect them, you can say wait until all of these things return, wait until some of the things return. There's a lot of functions or utility that you can build around the Promises API, and a fair number of the web frameworks are now beginning to adopt them, and it's possible that in future versions of JavaScript, the JavaScript APIs or the DOM APIs themselves will actually use promises. So you'll start to see more and more stuff like this in the future. So how does that apply to our secure local storage API? We have a fairly simple API where you say, get me a collection of secrets. You can name it whatever you want. You can have as many names as you want inside of your application. You can set keys. Now see, we're doing everything asynchronously. So if you want to know when it's done being written to the disk in an encrypted form, you can have a callback function, or you can just use set, fire, and forget. When you want to get a key out, you have to, because we're decrypting the data as we read it, you have to call the, you have to say get then my function. Same thing for delete. We also have, because we're talking about encrypted data and that decrypting that data every single time might be a little expensive, we have a fast function called has, which basically allows you to check for the presence of a key without actually decrypting the data, which might be useful in some circumstances. We have an asynchronous for each iterator where we can spoon feed you every key and value in your collection asynchronously without needing to wait, or you can then fetch them all, and then the promise will resolve when they're all done being fetched, and you can act on all of them all at once. And then we have a count function. Again, we can count all the records without having to decrypt all the data that you've stored, so you can know how many things you have without actually decrypting them. And finally, a simple clear function. So for anybody that's written like local storage, where you have to loop through all the keys and then find the ones that look like the ones you want to delete, and then you delete each one, this is a little bit faster. And we do this with one operation against the database instead of hundreds or thousands in number of operations per collection. So that is our simple secure storage API that we give you. So again, just to recap, HTML5, all your existing stuff just works. We encrypt it. But you're still limited by all of the restrictions of HTML5 in terms of file storage, and then the APIs that you have to use. With our API, you get a shiny, clean way of accessing your data, and it's immediately encrypted and always safe. So that's the storage API. Now, in my demo, I was showing Invoke, where you could have applications start to communicate with each other. And so how does that actually work? So because I said that we have multiple web views active inside of our container at any given time, we can do interesting things like invoke. So back to the chat application. Let's say the chat application, you wanted to put a little status indicator to say whether your IT contact was online or not when you looked at the screen. And normally, if you wanted to build that, you wanted to build a chat app that had, or a contacts app that had access to your chat server, you'd have to figure out what your chat server is, and you'd have to maybe download an API, and hopefully there's a JavaScript API for it, and then you have to bake that into your application. And then every time the chat application changed its API, you'd have to, or changed its interfaces, you'd have to update your libraries and rebuild and republish your contacts app. Not exactly the best, but with this, you can have a separate chat app and then talk to it from your contacts app, and you just need to maintain a simple API between the two of you, and you don't need any new code or libraries from the third party. So, for example, in this example, we've got the chat contact with a little black dot, and the contacts app will say, "Hey, Space, is there anything in my organization, any app in my organization that knows how to chat?" And the Space app will say, yes, I do have an application that knows how to chat. And what it'll do in the background is create that new web view and start loading that application. That application will boot up and do whatever it normally does. Communicates with the cloud. And as soon as it's ready to communicate, it will come back to the contacts app and say, yeah, here's a connection to that application. And what I can then do is say, okay, now I can start sending messages to it. And it'll say, hey, chat app, is there presence? What's the presence status for the IT help desk? And that might take a while because it might have to go back to the server and do a bunch of things. But eventually, at some point later, it'll come back and say, oh yeah, they are online. And then I can update the UI in my app. And so I get all this rich functionality that to the end user just looks like a dot turning from gray to green. But as you know, on the engineering side, the amount of work it takes to do that would be enormous. But if you've already got a chat app, you don't need to do anything other than make a few simple API calls. So let's see, I think I'm going to, for the sake of time, I'm going to skip the demo because I showed it at the beginning. But basically, here's what the API looks like. So I can get the chat app. And in this case, I'm just going to do a simple one. So I get the chat app, and then I have to wait for the app to boot up. So I have the then in there. And failure means either I don't have a chat app or I don't have permission to access the chat app. And then I can send. And once I have that connection, then I can start sending messages. So what does that look like? So I can say send, and I can send in an arbitrary block of JSON data, whatever information that application needs to interact with it requires to be interacted with. And in this case, I'm just saying open the chat room called services. And that could be any data you want. And in this case, I'm saying do it in the foreground. So when I call this, I'm actually going to switch web views from one to the other, and then the user can go off and do whatever they want to do in that web view. And so that's calling it in the foreground. And that's more of that particular example is a one-way communication. And in the second example, I'm actually going to go do something useful. In this case, I have a Photos app, and I want to select some photos, and then come back to the application with those photos. So I say, call the Photos app, and I send it a message saying I want to find all of the images that are tagged with space and keynote, and bring them back, and then let the user select from those. And then once they're done selecting, and the promise resolves, I then have a list of photos. And this is the only thing that this application needs to know about photos. Is there's an application called Photos, here's the things that I can pass to it, and then it gives me back the photos. That's it. You don't have to build the UI for browsing photos, you don't have to do anything on your app. You just rely on a different application doing that. Now, if you're an application that wants to provide services to other applications, it's a fairly simple API as well. So we have invoke onMessage. And when invoke onMessage gets called, or this callback function gets executed every single time someone calls you. So I might have, I think in this case it was the presence example, where I'm going to get a message that says, give me the presence for this particular user. So what I have to do is I have to create a promise now, and I return the promise. But in the middle, I need to actually do something with the message and then resolve the promise at some point. So I have this, I broke it out into a second slide just to make it easy to look at. But basically, the important point is I need to return the promise so that the calling application knows when it's done. So here's what the handle message function looks like. I have this get user function that's in my code somewhere, and I might have to go off to the server and check to see their presence. But eventually it comes back, and I get a block of data, and I construct a new one. I pull out the bits that I need to figure out whether they're connected or not in their status, and I return that promise, or I fulfill that promise with the response. So now I'm going to demo it really quickly here. If I can get the connector hooked up. All right. So actually, I don't want to be in the demo organization. I want to be in the JSON Corp organization. And I put in my PIN. And it's decrypting all the data that we've been talking about. And so now I'm in my organization. And I see the list of applications I've got here. And I've got this really simple invoke demo HTML page. And this is just an HTML page. There's no JavaScript frameworks involved. It's just a couple of buttons. And so I can say, get me. I can tap the get photos button. Oops, don't want to long press. And what it's doing is now I'm getting loaded into this is actually a Sencha Touch application that shows you photos. And if I open up the application browser or menu here, I can see that now I'm in the Photos application. I can select a few of these photos, hit choose, and now when I come back, I just console log out the the list of images that I selected. So I can do that again. Maybe I just want to select one image, maybe that one down there, hit choose, and you can see the receive success where I just have that URL to that image. And so that's a fairly complicated interaction that you would have to write a lot of code to do if you were building it the old way, but we think we can actually give you a fairly simple way to do it. Now here's another example I have of calling an application in the background. So I have, just to show that this can be done with any framework, I actually took the jQuery to do example and added some of our APIs to it and made it secure and then made it invocable. So here I've got the to-do application with nothing in it, but if maybe I can add something. All right, so that's working. I think I just hit that link. Let me go ahead and reload. Yep, go back. There we go. So there we go. Okay, so this is just the if you're familiar with the do MVC, it's a big website full of every single MVC pattern in JavaScript on the planet, and this is just the jQuery one. So that was the easiest one that everybody knows. So if I go over to this invoke, I've got this new to do button, and if I tap it, I get a line here that says success created true. All right, let me hit it again. So now I've hit it twice. I've never left, you notice I haven't left the app that I'm in or the web page that I'm on. But now, if I go back to the jQuery to-do app, the two messages that I created are now in here. I can do that again. So notice that there's two. If I hit it one more time, I've now got 3 messages. So cool. So I'm now this is both foreground. So now I've shown both foreground and background interactions with Invoke. So apologize for the switching here. But well, we see this as a low-level JavaScript API that represents a new way of building applications. So if you're building applications in the traditional way, whether they be a web app or a native packaged app that's a web app or just a regular native app, you have to take all of the functionality that you want the user to use and cram it into one box, into that one application. And if you're a typical enterprise, you might have multiple applications being built by multiple teams spread across the entire planet. And the to-do app might be written on one continent, the Photos app on another, and maybe the time tracking app is done in Bangalore. And you have to get all these teams coordinated, get all their application code, APIs, everything synchronized, build it, integrate it, and then push it onto the App Store. It takes a long time. And that's a lot of integration points, a lot of interaction, and all just to put an app together because we don't have the ability to create small apps that talk to each other. So with the Invoke API, we can take those apps, the functionality in that single app, break it apart, and create individual apps that do one thing and do it well, and then communicate with each other with the Invoke API. And we hope that the Invoke API can be something that can be built upon and maybe be implemented elsewhere or something similar to it, because we really think this is something that needs to be part of the web. So that is the Invoke API. Oops. So really quickly, the Space SDK. So to get all this functionality into your application requires a whopping 7 kilobyte download over the wire. But because we control the container, because we control the browser, your app never actually has to download it. We share that, and we version and share the SDK between all the web apps. So once it's downloaded once, it never gets downloaded again until the version changes, and then we automatically download a new copy. So your apps are always current. And that means your apps are auto-updating. And just to be clear, none of this requires Sencha Touch or any of the other Sencha technologies. So any app written in any web technology, anything HTML5, jQuery, Backbone, whatever you have, you can add the APIs to it rather quickly and simply. You drop this Space.js script into the head of your document. It's loaded off of our CDN. Whenever we see this URL, the Space client actually intercepts that request and uses a locally cached copy, so there's no network request made to fetch this file. And then the next question is, how do you get apps into space? How do you deploy an app into space? The URL. I mean, we've gone so far away when it comes to native packaging that we've kind of forgotten about the URL. It was the original way to deploy applications. And in space, when you're adding an application, you get a dialog with a name of an app and a URL, and that's it. You can then grant access to specific portions of the API, or specific sets of APIs. You say this application has access to the camera or it doesn't. And then you can say that this app provides these particular invoke endpoints, and you can then select the apps that it can then talk to. Because we already have the infrastructure to deploy apps with URLs, web servers, CDNs, app server frameworks. Am I running out of time? Okay, 4 more minutes. All right, so we got CDNs, we got app server frameworks. A lot of them that don't really work when you package your apps, because you have to take all your assets and maybe render them on the server and then package them up and put them in the app store. And this is kind of a pain. Browsers know how to consume the URL. The URLs can be shared, and URLs link things together. So I think we need to take a step back and figure out how we can get the URL back into our deployment methodology. And the other thing is, remember when websites just updated automatically? You didn't have to go hit the reload button or update your app. Every time you went to the app, it was always the current version. URLs are auto-updating, so we should have that too. And most importantly, and I think that like I said, packaging kills the URL. And with Sencha Space, we bring you back the ability to deploy with the URL. And I will leave it at that because I am just about out of time. I had one more demo, but I will skip it. So are there any questions? Actually, I do have this last slide. I'll put this up. So if you want to check out Space in more detail, sencha.com/space. All the examples that I've shown you here today are available on GitHub at the URL there. And please check it out. If there's any questions, I'll be outside. And yeah, so, and I'll also be in the Sencha booth at the front of the pavilion. So if there's any questions, anybody wants to talk about space, let me know. And with that, thank you.